Hi again, this is Mr. Ford, and today we're going to be working through Spearman's rank correlation coefficient. Now, this is just a measure of how strong and whether it's a positive correlation or a negative correlation. So the first thing we're going to talk about is the fact that it's also known as Spearman's rho, okay, represents the strength and correlation between two variables. So if we had a correlation coefficient of exactly 0, that means as this picture here, we have no correlation between those. Absolutely none. It's completely random, which is just as likely as getting an exact 1. It's actually more unlikely to get exactly random. So what we're going to have is we're going to have either values. We're either going to get, if we get something close to 1, what we're talking about is we're getting something that is positive, so it doesn't mean that it's a really up and down. Doesn't mean it's a really steep gradient. What it means is the closer it gets to 1 means the more tight it looks like, or the closer it gets to that line of best fit. And when it gets closer to this negative 1, then that means that this line here, it will be negative. So it'll be going down, and it means that the points will look closer and closer to a line, okay, where they'd match the line of best fit. So that's the first thing. So you have this range of numbers. You can't have a correlation coefficient greater than 1 or less than -1. The other thing we're going to do is we're going to be doing actually the calculation on how to do it. So we can actually, there's this formula, and you will generally be given it, or for those in places like geography, you'll be doing these sort of calculations through your coursework. So you'll get this formula here. So it's RS, so the rank, okay, for Spearman. So the Spearman's rank coefficient is equal to 1 minus 6 sigma del d squared divided by n cubed minus n. So there's lots of things there. Now it says underneath what they are, which is why you've got this pack. N just stands for the number of the results, so you can just take that away straight away. D stands for the difference between the ranks. Now I'm going to talk about what that actually is in a moment. It's very similar to standard deviation, which is we'll be doing shortly as well. And this sigma here looks like a 3, okay, looks like or a big E, looks like a backwards 3. It means sum of. So the sigma delta d squared, that means it's the sum of all of the d squareds. Okay, so it just means sum. It's a nice way for us mathematicians to be able to write sum of a lots of things. So let's actually have a look at a question and see how we would go about finding out. Actually, I'll take a moment. We'll come back to this, and I'm going to show you. There's a further question which gets you just taking a guess at what would the rank coefficient be. Okay, so before we do the actual calculation, which you do need to do, I've got this here. So you're given this question. So that looking at, there's 3 scatter graphs. I'm going to do the first one for you. There's 3 scatter graphs. Your job is to take a guess, and you can just circle what it would be. So looking at this graph, what would be the best guess for a rank coefficient? Okay, so if you look, if we were to draw a line through this, it's going down. So that means it's going to be one of these first two, because it has to be a negative, because it's a negative correlation. Okay, so the first thing, when you're looking at a question like this, you could sit there and you could even draw a line of best fit with a ruler, and you could say it's going to be a negative correlation. Now, because it's negative correlation, it can't be these, because the graph isn't going up. It's not a positive correlation. The next thing is, let's have a look. How strong is it? Well, actually, all of these points are quite close to the line. It matches this line of best fit quite well. I would say it is a negative 0.7, because if it gets to -1, that's a perfect negative correlation. Now, this isn't perfect, but it's pretty good. This is a strong negative correlation, so it's negative 0.7. Negative 0.2 would be very spaced out, and it would be a lot harder to draw it. Give it a go for the next two there and see how you go. and pause the video, and then I'm going to take you back and we're going to start doing some calculations. Now, I hope you've paused it and given a go at those other two there, taking a guess at what those would be. Now, here for our data, what we've got is the table shows GNI per capita and percentage of employment in agriculture of selected countries in 2014. So what we're going to do is we need to put it into this formula. So we have n, well, n is just going to be number of results. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is just going to be 10. The rest of it is got a little bit more work. So Spearman's rank. Okay, so that's it, Spearman's rank correlation coefficient. So what we're going to do is we're going to rank these here. So if we look at these here, what comes first? So the ones that come first is, and it doesn't matter what you do as long as it's the same for both of them. So if I do it in ascending order, so the lowest first being 1, then that's the first one I'm going to label. That means when I do employment of agriculture, I do the lowest first there. So Spearman's rank correlation coefficient, what we're really doing is we're looking for we're going to rank these. So the lowest values are these ones. So these would be first. Now, because they're first, that means the next one's going to be third. Okay. Now this one's quite tricky, but basically because these are 1 and 2, we're going to rank them both 1.5. So if you have repeated values, they basically take an average. Then it would be 1, 2, 3, 4. Next lowest would be 5, 6, 7, 8, 9, 10. So what we've done is we've ranked them. Now there's a little bit of trickiness here, but you've ranked, and you won't get, generally you shouldn't get this in the test. I've actually seen some and they don't do this to you, but these are the, as you're doing it, you're just ranking them. We've got to do exactly the same here, because what we're comparing is whether these match, whether there is a relationship between them. So let's have a look. What's our lowest value? 2. So this is going to rank 1. Then we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Alrighty. Now, hopefully you're starting to get an idea. What does D stand for? D stands for the difference in the ranks. Okay, the difference between the ranks. So the difference between these ranks, this one's 7. This one here is 9. 8 minus 3 is 5. 2, -1, but it doesn't matter, which is why we got D squared. 2, -3, 7.5, 5, and 8.5. All right, now I'm going to pause this and do this next section, and all you do is do D squared. Now you won't be given these, but you'll be given the formula. So Spearman's rank correlation coefficient, well, in this case, you need to go through and rank them, find the difference between the ranks, and then you're following this formula. Okay, so all I've done is I've taken my difference and I've squared them using my calculator. Okay, so just to recap, you rank them, since it's Spearman rank correlation coefficient, you rank them in ascending or descending as long as you're consistent. Find the difference in the ranks, then square it. Now, we're going to go back to our formula. Our formula for this is 1 minus 6 times the sum of all of the d. So we need to sum all of these d squareds. So I'm going to type this into a calculator and then I'll pop it in here. But just, I'm going to pause it. Okay, so typing this into the calculator, I get, when I sum them all together, I get 326.5. Okay, so what I've got is n is 10, the sum of d squared is 362.5. Okay, so now I can go about and start putting that into this formula. So the rank Spearman's is 1 minus 6 times 362.5 divided by n to the power of 3. So that's just 10. 10 cubed minus 10. I'm going to pop that all into my calculator. Okay, so just take your time with it. Make sure you get it right. And I had an arithmetic mistake, but I fixed it because I got a value that was outside my range, but 326.5. So when I type this in, I get negative 0.9787. Ooh. This means that there's a extremely strong negative correlation. So there's a almost perfect correlation there. I'm going to graph this and show you what it looks like. Okay. So what I've got is I've got a very extreme